So welcome to lesson 10. This is our last lesson for this unit, quadratic functions, but don't be sad. Remember I told you at the beginning of the year that you all love quadratic so much that it's split into 2 units. So we'll just do similar stuff in the next unit. So today's lesson is really just a summary of everything we've covered so far in the unit. So starting with this, the 3 forms of the quadratic equation. So we learned factored form, standard form, as well as vertex form. We looked at the advantages and disadvantages of each. We learned how to convert from one form to another. Essentially, what we're going to go through in today's summary is just what each form tells us and how we can get specific information from each form. So each form has its advantages and disadvantages. Let's talk about them. So standard form looks something like this. Whoa, I just said this. Like this. And the main advantage is that it's easy to find the y-intercept. So we haven't looked at this explicitly, but we can do it now. So let's say we have this equation. To find the y-intercept, all I need to do is let x equal 0. So f of 0. So because x is 0, I replace all of these x's with 0. So I have 2, 0 squared minus 3, 0 plus 1. What you should notice is that because you have 0 squared, which is 0 times 2, this becomes 0. So this whole thing is 0. 0 times negative 3, this whole thing is 0. And whatever the c value is, that ends up being the y-intercept. So standard form is nice because essentially when we set x to 0, all of these numbers disappear. It's only the c value that'll be left behind, telling us that the y-intercept is 0, whatever the c value is, in this case 1. The disadvantage, it really doesn't tell us anything about the vertex. So it doesn't tell us vertex or x-intercepts. If we take a look at factored form, so with factored form, the major advantage was it was easy to find the x-intercepts. Again, you should know the synonym for that is zeros. So remember, to find the x-intercept, we let y equal 0. So in this case, we would let y equal 0 and have these 2 factors copied as is. Then to solve for this, I set each factor to 0. So x plus 3 is equal to 0. So x is equal to negative 3. That's the first factor. And my second factor is x minus 1 is equal to 0. So x is equal to 1. So I get 2 different x-intercepts from here, negative 3, 0, and 1, 0. So with factored form, it's easy to find the x-intercepts. The disadvantage is that it's hard to find the vertex. Next, we have vertex form. Again, the advantage here is that it's easy to find the vertex. So if we take a look here, we know that the vertex occurs at hk, but we take the opposite sign of h. So here it's a positive, so we're going to take a negative 4, and we copy down this negative 4. The disadvantage, hard to find the x-intercepts. So what you can see here is that each form has its advantage. Standard form, it's easiest to find the y-intercept. Factored form, easiest to find the x-intercepts. And vertex form, easiest to find the vertex. So whenever you need to find x-intercepts, for example, you know that regardless of which form I give you your equation in, you need to convert it to factored form. Or if I wanted the vertex, the easiest thing is to convert it to vertex form. So we're going to go through the exercises. Again, a lot of this should be review. So I'm going to only do one example from each section, and then we're going to keep moving. So here it says, state the y-intercept of the following. So the exercises state the features that can easily be determined from the following forms. State the y-intercept of the following form. Again, we can do two things here. We know to find y-intercept, always we let x equal to 0. So in this equation, we will let this x equal to 0, this x equal to 0, and have plus 48. Again, you have 0 times a number, will cross out, become 0. 0 times a number, cross out, becomes 0. You're left with y is equal to 48. And remember, that just gives you the y coordinate. When it asks for a y-intercept, I do need a point, 0, 48. So you can do it this way. There's nothing wrong with that. You can also, in your head, realize this is standard form. When I put zeros in here, these will cancel out. So I should be left with my c value. So my y-intercept is 0, 48. So you should be able to do the other two. State the zeros of the following. Again, zeros is just another way of saying x-intercepts. So remember, to find the zeros or x-intercepts, we let y equal 0. So let's let y equal 0. So 0 is equal to x plus 8 and x minus 6. Again, to solve these, we set each factor to 0. So x plus 8 is equal to 0, and x minus 6 is equal to 0. And if I isolate for x, I have x is equal to -8 and x is equal to 6. Again, these just give me the x coordinates. I need points for the zeros. So here the x coordinate is -8 and the y I put in is 0. So one of the x-intercepts is -8, 0. Here the x coordinate is 6. The y I put in was 0. So my other x-intercept is 6, 0. Now I want you to be careful here, and this is why I emphasize that the x-intercepts aren't always the opposite of this. So here it is the opposite. We have positive a here and negative a here, -6 here and positive 6 here. But let's take a look at this example. We're going to follow the same process. So to find the zeros, we let y equal to 0. So 0 is equal to 2x minus 5 and x plus 6. Because I have two factors and they equal 0, I set each factor to 0. So 2x minus 5 is equal to 0, and x plus 6 is equal to 0. Now I isolate for the x. This one is quite easy. I just move the positive 6 over to give me x is equal to -6. Here it's a bit different. I'm going to move the 5 over first. So I have 2x is equal to, and -5 on the other side is positive 5. Then to isolate for x, I divide both sides by 2. So these cancel out. I'm left with x is equal to 5 over 2. So this is what I meant. You can't always just take the opposite of what you see in the factor to come up with the x-intercept. You always want to set the y to 0 and then solve for the appropriate x's. Again, we're not done. We need to put the actual coordinate points. So 5 over 2, 0. And -6, 0. Lastly, state the vertex of the following. Again, it's given in vertex form. This should be quite easy. Here is our h value, but we always take the opposite. And here is our k value. So I want you to try these and then check your answers with the bottom here. Okay, give me a few seconds as I switch to the next page. So graphing quadratic functions, in order to graph quadratic functions, we need to know the vertex. So remember, in order to graph all quadratic functions, so let me just do a quick review here. So graphing quadratics. So really, in order to do this, we need three different things. We need the vertex. We need to know if it opens up or down. And we need to know the step pattern. So 1a, 3a, and 5a. So in order to graph, we first need the vertex. Depending on the form of the quadratic function, we can find the vertex using different techniques. So here's just a summary of how we found the vertex before. If the function is in vertex form, we can read the vertex directly. And that's by taking the h and the k value. Remember, the h will have the opposite sign. If the function is in standard form, in order to find the vertex, we need to complete the square to get to vertex form. So this is what you spent the last 2 lessons doing. So remember, last video was for 2 different lessons. So hopefully you practiced completing the square, and that can take you from standard form to vertex form so that you can read it directly off of it. If the function is in factored form, we did show you another mechanism that you could use before the break. I just want to review that. So what you need to do is you need to find the zeros. Once you find the zeros, you need to find the x-coordinate of the vertex. And then thirdly, you need to find the y-coordinate of the vertex. And again, I'll review how to do that in this video. So here it says, change each equation to standard form and state the values of A, B, and C. This should be pretty self-explanatory. We did this yesterday, whether we're going from factored form to standard form or vertex form to standard form. It's just multiplying it out using FOIL. So I'll show you one more example, but I do expect you to do the rest on your own. So if we take a look at this example, we have f of x is equal to 3x plus 2 all times 2x minus 1. So here we have things being multiplied. We know we have to use FOIL. So 3x times 2x, we have 3 times 2, which is 6, and x times x, which is x squared. 3x times minus 1, so that's negative 3x. 2 times positive 2x, so that's 4x, and 2 times negative 1, which is negative 2. Don't stop there. See if you can collect like terms. And here you can. So we have 6x squared minus 3x plus 4x is just plus x minus 2. So pretty straightforward. We've been practicing these since the beginning of the semester, multiplying out polynomials. I'm not going to show you another example, but I do want you to remember that when I have a question like this and you see something squared, I want you to always write it out as x minus 3 times x minus 3 plus 5 before you actually work through the math. Okay, so I want to see these done, and then you're going to, essentially, every question we don't do in this review, you're going to take a picture of and you're going to send it to me so I know you know what you're doing. Here we have find the vertex for each quadratic function. So take a look. The first 2 are factored form, so we need to use the 3 steps that I mentioned here. The next 2 are standard form. So to go from standard form to vertex form, we have to complete the square. And if it was in vertex form, we would read the vertex directly. So let's review this process that we really didn't talk about much after the break. So the first step, so I'm just going to quickly show you these steps again. We need to find the zeros, find the x-coordinate of the vertex, and then find the y-coordinate of the vertex. So let's go back here. So the first thing is to find the zeros. We're in factored form, which is great. To find the zeros, we let y equal to 0. So I'm just going to do it on the side here. So 0 is equal to x plus 3 times x plus 1. Again, to solve these, we set each factor to 0. So x plus 3 equals 0, and x plus 1 equals 0. And now I isolate. X is equal to negative 3, and x is equal to negative 1. So I found the x-coordinates of the zeros, and so my zeros are negative 3, 0, and negative 1, 0. So this is all the first step. The second step is to find the x-coordinate of the vertex. So x-coordinate of vertex. And in order to do that, we take the average of these two x values. So remember, we discovered before the break that the vertex will lie halfway between the two zeros. And so essentially we're going to find, well, what is that halfway point between the two zeros? In order to do that, essentially what you're going to do is you're going to take the first x intercept value, so negative 3. You're going to add it to the second x-intercept value, negative 1, and you're going to divide by 2. So here we have negative 3 plus negative 1 divided by 2. This is the same thing as negative 3 minus 1 divided by 2. So that's negative 4 at the top divided by 2 is negative 2. This represents the x-coordinate of the vertex. Now I want to find the y-coordinate of the vertex. And in order to find the y-coordinate of the vertex, all I do is I take my x and plug it back into my equation. So I have f of negative 2. And because I replaced x with negative 2, I have to replace all of these x's with negative 2. So it's negative 2 plus 3 times negative 2 plus 1. So here I have negative 2 plus 3, which is 1, and negative 2 plus 1, which is negative 1, giving me negative 1. So I have the x-coordinate of the vertex. So let me write down my final answer. The x-coordinate of the vertex was negative 2. The y-coordinate of the vertex is negative 1. And now I have my complete vertex. So again, we didn't review this after the break, but I'm going to go through the steps again. So the first step is to find the zeros. So let me write that down actually. So find zeros. Okay, so you set the y to 0, set each factor to then 0, and isolate for the x values. The next part is find the x-coordinate of the vertex. So you take these x values and you're finding the average. So you take this value, add it with this value, and divide it by 2. That gets you the x-coordinate of the vertex. And if I have the x value of a point, to find the y value, I just plug it back in. So f to the negative 2 is negative 2 plus 3 times negative 2 plus 1. I simplify it, it gives me negative 1. Now I take the x-coordinate and the y-coordinate of the vertex and put it together to find the vertex. I know I've only done one example, but I do want you to try this on your own. And then once you're going to send all of this information as picture documents to me. We have this question. We're still trying to find the vertex, but in this case, they gave us standard form. And remember, to go from standard form to vertex form, we need to complete the square. So let's think about what we did yesterday in order to complete the square. So the first thing is we need to factor out the a value. If I take a look at my original question, my a value is negative 2. So that's what I'm factoring out. So negative 2 times what gives me negative 2x squared? Well, it's just x squared. And negative 2 times what gives me 4x? So 2, I have 2, I want to get to 4, so I'm going to multiply it by 2, and I'm going to multiply by x as well. So 2 times 2x gives me 4x. I want it to stay negative, so I have a negative here. To keep it negative up here, I'm going to make this positive. Again, check your work. Negative 2 times x squared is negative 2x squared. Negative 2 times positive 2x is negative 4x. Once you do this, remember, we're going to leave that gigantic space in the middle and copy down the c value. So that was the first step. The second step, we take our b over 2 squared value. So b over 2 squared. If I take a look at my bracket, my b value is 2, positive 2. So that's what I'm going to put in here. 2 divided by 2 squared. 2 divided by 2 is just 1. 1 squared is just 1. So once I have this value, remember I need to add that value in the bracket, but also subtract that value in the bracket in that order. So that's the end of step 3. For step 4, I don't like the negative value in the bracket. I want to take it out, but I know I need to multiply it by the a in order to do so. So I copy down everything else. The negative 2 I like. I like having the x squared plus 2x plus 1 in the bracket. Those are all fine. I don't like the negative 1 here, so I'm going to take it out. But to do that, I multiply by negative 2. So negative 2 times negative 1, remember the signs, is going to give you positive 2 plus the 3 that's already there. We're getting to our last step, and remember for the last step, there's really 2 things to do. This is a trinomial. We need to factor it. And we can just add our constants. So plus 2 plus 3 just gives me plus 5. Now I'm going to factor this. So I have x squared, so x and x. I have a 1 here, so 1 and 1. And now I do my double smileys. So 1 times x is just x, 1 times x is just x. And I want to get to positive 2x. So I know this is just going to be a positive here and a positive here. So positive here and a positive here. So remember, that's your biggest clue that you've done it right. Both of these should end up being the same factor. And then you take your, you rewrite your final answer. So the negative 2 is there. I have 2 of these x plus 1s. I rewrite them as x plus 1 squared, and then copy down the plus 5. Now I can put a box around my vertex form, but keep in mind that is not your answer because your answer was to find the vertex. So now I write down my vertex. Again, it's in vertex form, easy to read right off it. My h value is 1, but I take the opposite, so negative 1, and my k value is positive 5. Again, the vertex is important because we need the vertex to always graph. So if I tell you to graph this, for example, it's in standard form. You know you need the vertex. You need to complete the square, change it to vertex form before you can graph it. So a general rule of thumb for graphing, and I'm going to actually write this down. For graphing, convert to vertex form. Always. Because this also tells you now you have the vertex. You also know if it opens up or down. And using the a value, you can also find the step pattern. Again, you're going to try this on your own. Just give me one more second to flip the page. So here we're still on the same question where we want to find the vertex, but in these questions, they've given us the equation in vertex form, so super easy. The negative 4 is your h, but you always take, the opposite, so 4, and you take the k value, so that is the vertex. Okay, again, I want you to check your work after you do these questions, but you're also going to send them to me so I know you're writing out the steps properly. The last review we're going to do is finding the zeros of quadratic functions. So remember, zeros are just x-intercepts. There will be applications where it's important to find the zeros of a quadratic function, and the applications is what we're going to see in the next unit. So we can only find the zeros from factored form. So let's do a quick review. I'll do A and C with you. So here it's given in factored form, which is nice because I know that to find the zeros or x-intercepts, I let y equal to 0. So I have 0 equals to 2x plus 1 and x minus 5. I then set each factor to 0. So 0 is equal to 2x plus 1 and 0 is equal to x minus 5. So in this case, when I isolate, I bring the negative 5 over to become positive 5, so x equals 5. And to isolate for this, I bring the negative 1 over first, so negative 1 is equal to 2x. And to isolate for the x, I divide both sides by 2. So here, 2 divided by 2 would just become 1, so x. And we have negative 1 over 2 here when I divide it by 2. Again, don't forget, these are just the x coordinates, when you're asked to find the zeros, I need a point. So your x-intercepts are 5, 0, and negative half 0. I might also give you a question like this in standard form and ask you to find the zeros. Again, whenever you think I need to find zeros, you're always thinking a factored form. So we need to first convert this to factored form. And again, sorry about that. The way we go from standard to factored form is we essentially just factor. So we're going to take a look at this and we are going to factor it. So it's a trinomial and we have 2 brackets. Here, the first term is 6x squared. So we know to deal with the x squared, we're going to have an x and an x, but we need to deal with the 6. So for the 6, we can have 1 times 6 as a possibility, or 2 times 3. Again, always start with the closest figures. So we're going to start with 2x in one bracket, 3x in the other. Again, a reminder that it doesn't matter where your 3 or 2 are, as long as you're using 3 and 2. Then we take a look at our last term, which is 1. To get 1, we need to do 1 times 1 here. That's the only possibility. Let's do our double smiley. Here we have 1 times 3x, which is 3x. Here we have 1 times 2x, which is 2x. I put my little circles to say I need to put a sign there. So both of these should add up to give me positive 1x. So if I do positive 3x minus 2x, that's 3x minus 2x gives me a positive x. So because the positive is attached to this, I put the positive here. And because the negative is attached to this, I put the negative here. But all you've done right now is converted standard form to factored form. Remember, the question was to find the zeros of the quadratic function. So there's no space there. I'm just going to do it down here. So we have this in factored form. To get the x-intercepts, I let y equal to 0. So 0 is equal to 2x plus 1 and 3x minus 1. Again, in order to solve for the x's, I set each factor or each bracket in this case to 0. So 0 is equal to 2x plus 1, and 0 is equal to 3x minus 1. And now I isolate for the x's. So I first move the 1 over to make it negative 1 is equal to 2x. To isolate for the x, I'm going to divide both sides by 2. So here I have x, and here I have negative half. And similarly here, to isolate for the x, I first move the negative 1 over. It becomes positive 1 equals 3x. And then I divide both sides by 3 to isolate for the x. So x is 1 over 3 because these 3's cancel each other out. Again, don't forget to put your final answer down in a proper form. These are just the x coordinates. So my x-intercepts are negative half, 0, and 1/3, 0. So those are my final answers. So you can see we skipped a lot of questions on this review because it is supposed to be a review. Try these questions, then take a picture and show me your answer. The homework says complete the chart on the next page. So again, this is just a wonderful summary of everything we've done so far. I have an equation in factored, standard, and vertex form. You're going to find the vertex for all 3. You're going to give me the domain, range, x-intercepts, y-intercepts, axis of symmetry, opens up or down, max or min value. I'm going to give you a hint. It will help to graph the equation first, and then you can get all of this information. So don't forget, in order to graph it, you do need to be able to convert everything to vertex form. Okay, so again, once you do this, you will submit this page to me. Thank you.